what we're discovering when you look at the actual kind of climate elements that we want for our animals, we find that our sows are here and our piglets are way up here, and there's no intersection in between the two of them. So most farmers try to sort of split the difference and run those barns so that the sows are kind of they're hot and miserable, and the poor piglets are shivering. And we have to find some way to kind of accommodate both stages of the life cycle in order to protect the animal welfare and improve our actual performance of those animals in the barn.
Well, good day. My name is Ruud Zelstra, and I'm the host of another episode of the Swine podcast show in Canada. And with me, I have today Dr. Bob Stwalley from Purdue University. Welcome, Dr. Stwalley.
Thank you so much for having me on.
You're welcome. Today's topic will be to cover an interesting discussion around control of the microenvironment in the swine barn, and particularly how cooling pads of the floor may help with that. So, Dr. Stwalley, why is fighting thermal stress in pigs, in swine, important?
Well, actually, it's a very interesting problem that is a relatively new problem. If you go back to, say, 1980, and let's call that 40, 45 years worth of change in the genetic makeup of our animals, you actually discover that, well, not only were the litters that our sows were producing smaller, but not only that, the actual exothermic activity, the metabolism of the sow was lower too. And during the intervening time, then, our geneticists have bred for more piglets, because that's what we all want, at the in the farrowing barn. And of course, a couple of things have happened. The sow's uterus hasn't gotten any bigger, and so our piglets, in order to get more of them in there, are born with far less adipose fat than they used to be years ago. And so the cute little piglets are far more vulnerable, and mom is producing so much more milk, and milk lactating is the most energy extensive thing that a mammal can do. And so her metabolism has simply gone through the roof. And what we're discovering when you look at the actual kind of climate elements that we want for our animals, we find that our sows are here and our piglets are way up here, and there's no intersection in between the two of them. So most farmers try to sort of split the difference and run those barns so that the sows are kind of they're hot and miserable, and the poor piglets are shivering. And we have to find some way to kind of accommodate both stages of the life cycle in order to protect the animal welfare and improve our actual, performance of those animals in the barn. So basically, an awareness of this problem was what got us kind of started down the road to the creation of these floor cooling pads. Once we had sort of a physical inkling of the actual problem, my partner, Dr. Alan Schinkel from Animal Sciences, and we sat down and looked at it from what I would call a business marketing perspective. And Alan and I interviewed numerous producers, talked to barn managers, talked to veterinarians, experienced hands. And pretty much it was uniform across the industry, at least from the sampling of the experts that we talked to, that this thermal stress was drastically affecting our sows. And so we set out to kind of solve that problem And that required then that's sort of where I come into it. I'm the engineer here, and I'm a thermo physical fluids person. And so we set out to design a floor cooling unit, which would take advantage of the animal's behavior. Uh, we wanted the coolant to be non toxic, so that pretty much limits us to just groundwater, which is fine. And then one of the big things that our interviews with the owners and the foremen in the barns and the field hands was like, whatever you put in here, you can't add work for us. And so we made very certain that we had a device that was basically going to be about as foolproof as we could make it, that would be an install and forget kind of affair, and essentially a unit that would go in and allow that sow to exist in a warmer overall ambient environment. But she thinks she's laying in kind of a little cool spot, a kind of a nice wallow that's got a wonderful, comfortable floor for her. So that's kind of the genesis of that product.
Interesting. So the focus is lactating sows because they're so heavily metabolizing and therefore, of course, producing a lot of heat. Because regardless of how efficient a process is, inefficiency means heat production. And then, are you then with this floor pad that you're describing, covering the floor of the entire pen that the sow is laying in, like the crate part where the sow is laying in the fair?
Just inside her crate. So the piglets are still outside, and we're still able to get to them with warming pads and elevate their temperature a little bit, or provide them with a little bit of extra heat into their environment. But we're able to draw between 400 and 500 watts of heat away from the sow, and that is actually enough to take a thermally stressed sow who's maybe up at 120 breaths per minute, and within a half an hour or so, we can have her comfortable in under 40. So we have a control mechanism on there so we don't overcool the units. But again, we have seen some very dramatic, I guess this would be a quantitative or qualitative result, pardon me, just happy sows. They laid out on these and they're very happy. Now, I would be remiss if I tried to say to you that the only thing that we've worked on has been the sows. That was kind of what we thought was our initial target for it. It turns out we've also had some excellent results in boar studs. The boar, of course, if it gets overheated, he's a very voracious eater, and if he's not being productive because you've overheated his crown jewels, well, you're going to be feeding that animal for several months before his productivity recovers. So we have also discovered that our farmers who are operating boar studs are very interested in this type of a product to keep their gentlemen cool as well.
So how do these cooling pads actually work? You mentioned groundwater, so probably going through these cooling pads. So what material would the cooling pad be, and do you have any kind of control of the surface temperature of the cooling pad that you can regulate perhaps?
Yes, sir. That's the excellent question. So what we do is we control the flow rate of the water through the units to control the heat transfer rate away from the animal. That's done basically with just a simple flow control valve. The units themselves are made out of rather durable material. The primary metal in the whole thing is going to be aluminum, and that will be fastened to a polyurethane base. And then the actual heat transfer tubing inside is copper, but we protect it with coatings from the actual environment and try to keep it sealed in so it's not exposed to the actual kind of corrosive environment of the hog barn.
And then what can you then, so you control the temperature drop or the cooling activity using flow rates. So is there then kind of a sensor tied to that?
It depends upon the manifestation of it. We have tried it multiple ways. We've tried it on a clock. We have also tried it on a sensor. Both means are effective. It just depends kind of on how much someone is willing to invest in the unit and the control system on it. We certainly found that a thermal trigger was probably the most accurate, but from a production perspective, we discovered that perhaps just running it on the clock works almost as well. Not quite. And it doesn't give you kind of the direct feedback, but it keeps the overall unit much simpler and much more operational. And again, we've not really had any problems associated with the feedback issues, which might come from a time-controlled system.
So then, working on the clock, that means then during night when it's hopefully cooler in Indiana, you don't need to run it much, and then during the day when it's very hot, you can run it faster. That's how you work it.
Absolutely. And then if we were to move down, somewhere on the Gulf Coast where you had warmer temperatures, you might run it further on into the evening to try to keep your animals, comfortable there, and maybe only have a few hours down, or maybe even during a hot stretch, it might run 24 hours a day.
Yes. Yeah.
But again, we're using nothing more than basically water at essentially a modest ground temperature. So once you get down a meter or so in depth, any water sitting in a pipe is at roughly somewhere between 15 and 18 C. And that's almost perfect for our coolant.
Yeah. So when you then look at how producers would use these coolers in the barn, will this pad actually increase or not the daily workloads in the barns?
We hope that it will not. Again, our intention and the original design in these units was once they were installed and in an operational state, this should not interfere with your activities inside the barn. Now, of course, if a pipe gets broken or somehow you have to go in and do some maintenance, I mean, all bets are off on that situation. But no, our objective was that these units should basically be kind of fire and forget, and that again, we were very clearly told up front that whatever you do, you cannot add to the workload of our people in these barns. So Dr. Schinkel and I were very, very conscientious of that, and certainly our group that has taken it on and is running it to commercialization is also extremely aware of that.
How do the sows interact with the cooling pads? Like I've worked with pigs a little bit, and I noticed that pigs are very good destructors of many kinds of materials in a pen. So what do the sows think of the pads?
Well, I will tell you the interesting story on this one is that at Purdue, we use undergraduate students to start research projects. And Dr. Schinkel and I had some undergraduates build the very first one of these. Now, it didn't have the plastic under it. It was wood. And like I said, it was a very primitive thing. But he had a hole out in the farrowing barn where we could test this original first unit. And we took it out there and we installed it. And oh my gosh, it was summertime and he turned the furnaces up and he was spraying water in the air, and it was miserable in that barn. And we herded a pig into the stall that we had this thing in, and she's a little bit grumpy. I mean, it's a warm barn, and she lays down on that, and then she kind of hookers in and gets herself comfortable. And literally, she looked up at the two of us and kind of grinned and smiled. So it was very obvious that no, the pig was comfortable laying on this nice cool pad. So again, it has been very gratifying in that regard. You're dealing with a smarter animal there, and they recognize that you're trying to do something nice for them. Now, as far as the ability of the animal to tear stuff up, we've also recognized that. And so, oh my gosh, any wires, any tubes, anything like that have got to, go through guarded runs. And again, we also wound up then having to protect wires and things from the piglets that are kind of in there with her. So, no, they're very curious, very, very sharp animals. And it's just kind of up to us to be a little smarter.
So then following installation of the pads, what kind of operating costs should producers be aware of? Like we talked about water, we talked about some other aspects. So,
well, that sort of depends then on how the producer intends to operate these units. All right. If you had a pit under the building and you had plenty of lagoon capacity, you could simply run water through it and be one and done and just dump to the pit. All right. In that situation, you have really almost no cost other than the associated additional water that you would pump. On the other hand, there are, let's say you're a more limited sized lagoon owner and you don't want to just flood, additional water into that unit. Potentially then a recirculation plant for chilled water would be an appropriate addition to your barn. And, then you would obviously have the capital costs associated with that and pumping that water back around. So I'm certainly not going to say that it would be a free, type of installation on things. But I think what you would need to do is go back and look at our data on performance of the sows and against the control animals, and see that they eat better, they're more productive, the litters wind up being bigger. Again, the actual dollars and cents performance of the animals improves when you utilize this compared to animals that are just allowed to swelter in the heat. So there is absolutely a definitive cost savings if you're willing to sit down and do the math.
Yeah, in other words,
you can make this pay for itself.
Yeah, so the big return of investment is increased performance of the sows because the cooler, they can therefore better express their voluntary feed intake. In other words, eat more energy and produce more milk.
Absolutely. And again, the milk production aspect then is where your piglets wind up coming out of the farrowing barn ahead of the animals that were in the control groups.
So obviously you've done some experiments then with sows in testing these pads. Like what kind of environment was the testing done in? Was it at Purdue University or was it in commercial practice?
We have, there are commercial tests going on right now with IHT Group. The testing that Purdue University did was in both the what we call ANSHREC, which is our animal science research farm, and then we did some additional testing at the USDA animal behavioral laboratories. So there have been numerous series of tests associated with this. We're very comfortable that our data on improved performance with these units is very rock solid. But I mean, even backing up earlier than that, I can tell you that before we ever did anything other than just kind of that initial animal run with it. We spent a great deal of time actually in the engineering laboratories, doubling down and making certain that we understood what our heat transfer rates were going to be, where we needed to have our coolant flow rate dialed in at, and all of the different little aspects about controlling that unit. Once we were happy with an initial design, we then produced probably about 50 to 60 of these pads at the university. With student help, and then we took those out to the animal science farms and actually ran. Our animal science partners are very big into statistics and making sure that when they say things, they can say it definitively. And we were the support group with regard to that, but we've run multiple farrowing cycles through these units, and again, basically, we can very much show the improved performance of our animals on these, and we've done so by artificially ramping the barn temperatures up. Doing lots of other things that would simulate, a mid-August kind of hot spell.
So sometimes we hear about temperature that you may read on a thermometer, and then we also discuss effective temperature that the animal experiences. So what kind of a difference between the two do you think your unit can change as the local effective temperature for the sow that is laying on the cooling pad?
Well, that's actually very interesting, because we have discovered that it's not only a local reaction, but it's a reaction to the flesh of the animal in there, because we've taken temperature readings basically of the animal as it's laying down, and then it happens to get up and go have a nibble of food or a drink of water. And you can literally watch that side of the animal's flank then warm up. And of course, our instrumented pads, then, you can see the reaction differently in there. We're actually kind of convinced enough as Dr. Schinkel and I look forward, we think maybe from a well-instrumented pad, we can actually even determine the animal position by the change in the heat transfer going into the pad. So again, a very, very interesting question. And I'm not sure that we actually modify the ambient air around the animal at all. I think we're really directly modifying kind of the near surface flesh of the animal. And again, they seem to like it very much, because they'll get cool on one side and then they'll kind of reposition and get the other side down. And like I said, they're very aware that this is a comfortable thing to lay on.
So swine barn conditions are tough. So how durable are these units?
Well, I'd like to believe that they're quite durable. On the other hand, you're absolutely right. Swine and swine barns are one of the toughest environments I think I have ever, as an engineer, had to work in. And from my perspective, again, as a modern engineer who's very much into electronics, oh my goodness, we've had to put some of our electronic materials into atmospheric isolation boxes just to keep the parts running. So again, this is a real issue. And one of the things then that we have attempted to do is to try to move most of those control systems kind of maybe back off into another room where we can control the atmosphere a little better, and again, sort of keep the electronics a little bit separate from right out there with the hogs. On the other hand, we have worked very, very hard to make the heat exchanger extremely durable. Again, it's significant in weight, so it's not something that they can just kind of easily bump around. It has some mass to it, and again, it's made out of a rolled aluminum plate and some hard plastic. So even if they play with it very rapidly, they find something else that's a little more rewarding to make noise with or play with.
It's time for our famous three. Fumonisins are one of the most prevalent mycotoxins in North America and can impact the performance of your feed and your pigs. MycoFix Fumezyme is the first ever CFIA-approved purified enzyme to specifically and irreversibly degrade fumonisins into non-toxic metabolites. Protect your pigs from fumonisins with MycoFix Fumezyme. Learn more at dsmfirmenich.com/MycoFix. That's dsm-firmenich.com/MyCoFix.
I just have two slightly different questions just to follow up or to end the conversation with. First of all, what is your favorite swine-related resource that you like to look or read it?
Well, I am an engineer, and so I kind of have two of them that for me are very, very important. And, I think the first one has to be the Guide for Care and Use of Agricultural Animals. That's the Federation of the Animal Science Societies. And I mean, that just gives me as the engineer, hey, here are my constraints for the animal. Here's where I have to be with that. And I guess as far as the second one of those is concerned, I am a huge fan of the old Midwest Plan Service farmstead guides and building guides. And I would tell you that the reason all of our farm buildings are different is because all of our farms are unique. And each of us has different things that needs to happen in our own local environment. And I've just always found that's just a plethora of just really interesting ideas about how you might set up your livestock operation.
Yeah, interesting. So from your perspective, what sets successful professionals apart?
I think that is also a great question. And as a professor, one of the things that I spend an awful lot of time on are teaching my students not just what's in kind of the title of the course, but also professional skills that will help them in their careers. And the one that I see that just really rings true, I would term curiosity. You have to be curious about what it is that you're doing, and that then engenders a willingness to learn and keep learning and become the best that you can be. And so, if I had to say anything, it would be that your best operators out there are the ones who realize that they don't know everything, and that, oh my gosh, every day is an opportunity for me to do better and make a difference that's positive and lasting.
Interesting. I agree with those comments you made. So that concludes another episode of Swineit podcast in Canada. So thank you for joining us today, and especially thank you, Dr. Stwalley, for your interesting insights.
Thank you very much for having me.